Hello, we continue with Unit 1. My name is Elias. In this video, we are now going to look at the derivation of the multiplier and see how the Keynesian cross can help us to determine or to evaluate the business activities in a given economy. Okay, so let's first describe what we did in Unit 2 where we looked at the circular flow of income and determined the withdrawals and injections. Now recall that equilibrium in the economy is reached when withdrawals equal injections, that is W equal to J. Now when any of the injection variables increase, aggregate demand will grow by more than the increase in the injection variable due to the multiplier effect. Now we have not derived this multiplier and explained how this will be the case. So if, for example, investment increased, we expect GDP to also increase. But the increase in GDP will not be equal to the increase in investment, and this is because of the multiplier effect. So what we need then is to derive this multiplier that we will be using for us to determine the level of economic activities. So with the multiplier effect, for example, an initial increase in aggregate demand of 100 kwacha leads to an eventual rise in GDP that is greater than 100 kwacha. And this is because of the multiplier effect. Now when withdrawals equal injections, it means that GDP will stop rising, and this will be the equilibrium position. When there is a gap between the two, it means there will be some changes needed to be made for equilibrium to be restored. Now, if there is an increase in income for the households, then the withdrawals will also receive an upward pressure. I will leave this one for you to figure out why this is the case by reading Essential Economics for Business. Okay, let's quickly rush to the Keynesian cross. So with aggregate demand being equal to consumption plus withdrawals, and aggregate expenditure being equal to consumption plus the injections, then equilibrium will be reached when aggregate demand is equal to the aggregate expenditure. Now let's show this using the Keynesian cross. So using the Keynesian cross with a line passing through the middle at 45 degrees, measuring the aggregate demand and the actual expenditure being the blue line here, we notice that equilibrium will be reached when the aggregate expenditure and the aggregate demand lines meet. And this is at point E here, and we've denoted this as GDPE. Now, what will happen if aggregate expenditure was more than the demand? Now, with an economy at GDP1, you will notice that aggregate expenditure here is more than the GDP. And as such, for equilibrium to be restored here, it means that GDP will have to increase until the two are equal at point E. If on the other hand, aggregate demand or GDP was more than the expenditure, then it means that the GDP will have to start falling down until equilibrium is restored. And you will notice here that we have a dotted line here which is measuring the consumption, and to this consumption, when we add the autonomous injections, the line will shift. It will be a parallel shift upwards to where we are measuring our aggregate expenditure, which therefore tells us that the two lines will be the consumption line and the aggregate expenditure line will be parallel to each other. Let's let's develop the model and come up with a multiplier. Beginning with a simple economy where we only have the households and the firms, we saw earlier on when we were looking at the circular flow of income that aggregate demand will be equal to consumption plus investment. or income will be equal to consumption plus investment. And if we define consumption to be C plus BY, where C is the autonomous consumption, that is the consumption that doesn't depend on income, and this measures this is the marginal propensity to consume, which measures the amount by which consumption will increase for any change in the income. And then we also assume here that investment is autonomous, so we are putting this bar to show that investment will not depend on income. It will just be a fixed amount. With that, then bringing these two into this model, where we see C, we substitute and put this, and where there is I, we put this, the autonomous investment. Then what we will have is that Y will be equal to C prime plus BY plus I. So this prime here, because we say this is autonomous, so it will have a prime there. So this becomes our GDP equation, or our aggregate demand equation, when we define what consumption and what investment is. Okay, so let's now take it to deriving the multiplier. So starting with our initial equation that we've just developed, that income is equal to consumption, autonomous consumption, plus consumption that depends on income, where we're measuring the marginal propensity to consume and the income here, plus the investment. Then if we take BY the other side, what we will have that then will be a minus here, and then this side we will remain with consumption plus investment, because BY will go to the other side. And if we factor out Y, we will remain with 1 minus B. So if you factor out Y here, there will be nothing, so there will just be 1 here. So that when you multiply Y times 1, you will have Y, and Y times negative B, you will have negative BY. And this will be equal to our autonomous expenditures. By dividing through by 1 minus B, what we have then is that we will have 1 minus B here, which will cancel each other, so these two will cancel. And then we also do the same this side. So by dividing by 1 minus B, it means we have 1 divided by 1 minus B, because this is multiplied by 1. And we do the same here, we'll have I prime divided by 1 minus B. Okay, and so if we write that with a smooth equation, what we have then is that we'll remain with Y this side, is equal to autonomous consumption multiplied by 1 over 1 minus B, plus autonomous investment multiplied by 1 over 1 minus B. Now there's something interesting here about this factor that we have just developed. So this factor is called the multiplier. We in this course, for this particular sessions that we have, for these sessions, we are going to use K. In other books, you may find M or any other symbol. It's just a scalar. It has no meaning. But however, this ratio here, this factor here, is the multiplier. And from there, we see that we use this multiplier to know how much, by how much income will change for any change brought about from autonomous investment. And we call this then the investment multiplier. So if investment increased, say, by 40, then we will have to multiply that 40 times the multiplier to know the amount by which income will change. Hence, the reason why we said that for any change in the injection variable, income will increase by more than the initial change in the autonomous injection variable due to the multiplier effect. So it is also true that if autonomous consumption, that is this consumption here, the consumption that does not depend on income, if this consumption changes, income will also change. And just like autonomous investment, the change in income will be more than the change in autonomous consumption because of the multiplier effect. And therefore, change in income will be equal to the multiplier multiplied by the change in autonomous consumption. Let's look at an example. Suppose that consumption is equal to 50 plus 0.7y and the level of investment is 30. And from here then we want to find the level of equilibrium income in this economy. Now before we move on, it will be good for us to look at this equation and relate it to the model we developed. So consumption here is equal to 50. This 50 here, as you can see, has no y. Therefore, this is the autonomous consumption, the small c. That is the consumption that does not depend on income. And then plus 0.75y, this 0.75 is called the marginal propensity to consume. It shows that for any unit increase in income, consumption will increase by 0.75. If income increases by 100, it means that consumption will increase by 75. So this part here is called the marginal propensity to consume. And the y here is our income. Notice also the level of investment being 30. So it doesn't depend on anything, meaning it is autonomous. So for us to find the level of equilibrium income, we need to push bring our equation. So remember that y in this simple model is equal to C plus I. Consumption plus investment. And this is equal to consumption is equal to 50 plus 0.75y, 0.75y, and then plus investment, which is 30 in this case. Okay, so this is y here. So this means that if we take this guy the other side, we have y minus 0.75y will be equal to 50 plus 30. And if we simplify this, y minus 0.75y is equal to 0.25y. 0.25y will be equal to, and this part here will give us 80. And then if we divide through by 0.25 to get our y, and here we divide by 0.25, 0.25, then it means that our equilibrium income, which we can denote as y star, will be equal to 320. So this here then becomes our equilibrium income. The next question is asking us to find the size of the investment multiplier, which if you were following through, you will notice that the investment multiplier is just 4, because we were dividing by 0.25, which gives you the 4, but we are going to show that. And then suppose that investment increased by 20. What is the resulting change in income? Let's get the solutions. So the first one was to find the equilibrium level of income. So y is equal to consumption plus investment, and we know that our consumption is 50 plus 0.75y, and the investment, it was investment 30 or 20? Okay, investment is 20. Okay, let me put 20 here so that we follow through with that example. Okay, so what we have then is that we have y minus 0.75y is equal to 50 plus 20, and then 0.25 is equal to 70, and then when we divide through by 0.25, what we will have then is that equilibrium income will be equal to 280. So remember, we've gone with the 20 here because we assumed that investment was we saw investment being 30, but in the calculation here we used 20. So we will go with the 20 because computation will be the same. So just put 20 where there is 30 on investment. The second question was asking us to find the size of the multiplier. So by definition, multiplier by computation, multiplier was equal to 1 divided by 1 minus b. And if you put b here, which is the marginal propensity to consume of 0.75, we will have 0.75 here. And this whole thing will mean 1 divided by 1 minus 0.75 will be 0.25. And if you divide 1 divided by 0.25, you'll get the 4. And this 4 is the investment multiplier. Okay, so to find the change in the income brought about by the 20 change in investment, recall we said change in income will be equal to multiplier multiplied by the change in investment. And doing that, we noted that investment changed by 20. So we multiply 4, which is a multiplier, times the change in investment of 20. And by so doing, we will obtain our change in income of 80. Meaning that if investment changes by 20 or increases by 20, our equilibrium income will increase by 80. Therefore, income increases by 80. And from the above example, we can therefore conclude that income equals multiplier multiplied by autonomous expenditure. And therefore, this means that Y star, which is our equilibrium income, will be equal to the multiplier multiplied by the autonomous expenditure. So if you looked at the one we had, our autonomous expenditure there was consumption plus the investment. Now I'm putting these primes to mean autonomous consumption here and autonomous investment. And this part there was 50, and this other part here is 20. And if you multiply these two, you add these two, you will have 70 here. Okay? And now that we know the size of our multiplier, which is 4, it means that equilibrium income here will be equal to 4 multiplied by 70. The 70, which is the autonomous expenditure, and this whole thing will simply give you 280. So to get equilibrium income, you can either use this approach or what we have done, you will still get the same answer as long as you know the size of the multiplier and the size of the autonomous expenditure. Okay, so and then if we want to get the change in income, we obtain this by simply multiplying the multiplier times the change in autonomous expenditure. So you may find that autonomous consumption increases, autonomous investment increases. It means for you to get the change in income, just bring the change in autonomous expenditures together and then multiply that by the multiplier. Okay, so thank you very much for watching. If you have questions, remember to send an email to moauelias@gmail.com. I will see you in session 5, where we will continue looking at determination of business activities, and specifically we are going to include the government into our income determination and derive the multiplier. Bye-bye.